Today we will deal with the problem of communication between parallel loops. Let us assume that we need in two different while loops to generate simultaneously the waveforms of a cosine with different frequencies. We would like the two loops to end the same time after pressing the stop button. In this example, the stop button is placed outside the while loop and its value is passed to the inputs of the while loop. Let's start the program. As we can see, the cosine waveforms are displayed in charts with both loops. However, if you press the stop button, nothing happens. Why? Both two loops work endlessly because the stop button is out of the loops and only one time after the program is started, it will pass the false initial value to the while loop input. So maybe we should move the stop button inside the while loop. Now we see that only the first while loop works and the cosine waveform is displayed on the chart. However, after pressing the stop button, loop 1 has finished working. One value from loop 2 was displayed on the loop 2 chart and the loop also ended. The effect is not satisfactory because two loops should work simultaneously. However, in this case, the second while loop will wait for all input to the loop. Thus, only when you press the stop button, the true value will be transmitted from the first to the second while loop. The while loop will only execute once and exit. So how should we correctly do this task? For this, we will need local variables, which enables reading or writing a given value from a control or indicator placed on the front panel from many places on the block diagram. One way to create a local variable is to right-click on the control or indicator and select Create Local Variable. So let's modify our example. Put the local variable in the second while loop, removing the direct connections between the loops. By default, the local variable is writable. To read data from it, right-click and select Change to Read. The program will not start because the mechanical action of the button cannot be latched. Let's change it to switch. Let's run example. We now see that the two waveforms are displayed on the graphs and after pressing the stop button, the two loops will end. Local variables are useful for communication between parallel loops, however, they have a major disadvantage. Let's assume that we would like to increase the value from the value control by 1 in one loop and in another loop reduce this value by 1. For ease of reference, the result is also plotted on the plot chart. In each loop, a delay has been added that can be adjusted. We would expect that if the delays are the same, the value should be 0. However, we see that the values is not always increased by 1 first, and then decreased by 1. As we change the delays in our loop, the more difficult it is for us to predict which loop will be executed first. Thus, we can see that we are not able to predict what value the value control will have. This phenomenon is called race conditions and is the result of a lack of control over the flow of data. To prevent this situation, avoid writing the value to a control or indicator in many places in the code.